Hello and welcome back. We have a request to do revision about Kirchhoff law, so I prepared 3 questions in this video discussion. If you haven't watched my previous video about Kirchhoff law, I would suggest you to do so before this video so that you can have better understanding. So let's see the first question from STPM 2016. So you are given with this DC circuit and we're going to find the value of I1, I2, I3. So we have 3 unknowns, so we'll need at least 3 questions to solve this question. First is Kirchhoff current law that states the sum of the current entering the point equal to the sum of the current flowing out from the point. So looking at the circuit, we can see I1 and I2 are entering the point, while I3 is flowing out from the point. So we have the first equation as I1 plus I2 equal to I3. And then we're going to use the Kirchhoff voltage law. So either clockwise or anti-clockwise. So to make the work simple, we should choose wisely. So usually I would observe the EMF source. That in this case, I'm going to draw a anti-clockwise direction because it flow out from the positive terminal of 12-volt battery. And also in addition, we have I2 and I3 follow the direction of the loop. So with this, we have positive 12 volts equal to 2 I2 plus the voltage of 6 ohm, which is 6 I2. This is 6 I3. Okay, so that is the second equation we can get from the question. And then we're going to draw the second loop. So I would suggest a clockwise direction because it flows out from the positive terminal of 6-volt battery. So here we have positive 6 equal to 1 I1 since follow the direction of the loop plus 6 I3 also follow the direction of the loop. So either positive or negative, I have mentioned how we can use it in the previous video. So make sure you understand and apply it in the question. So we also can draw a big loop to get fourth equation, okay, for maybe for checking purpose. So I would suggest a anti-clockwise direction. So because 12 volt is bigger than 6 volt, so I would expect the current will flow in this direction. So here we have positive 12 volt minus 6 volt because you can see that the loop is flowing into the positive terminal of 6 volt. So it will be denoted as negative. And then we have the voltage across 2 ohm, which is 2 I2. And as for 1 ohm, so you can see I1 is against the direction of the loop. So it will be minus I1, 1 I1. Simplify the equation, we have 6 equal to 2 I2 minus I1. So that is the fourth equation you can get. And you just need 3 of them to do the question. So the fourth equation here can serve as checking answer purpose for you to make sure that everything is correct. So the answer is here. So I'll leave the simultaneous solution for you to do it on your own. So I just want to discuss about I1. So you can see it has a negative value. So don't panic about negative. It just means that the current is in another way. So which I've discussed previously. So we're going to the next question from Kelantan module 2. So we're going to do the same thing. So first we need to get equation from KCL, which is we can look at point A. So we can see I1 is entering, I3 is entering, while I2 is flowing out from the point. So the first equation is I1 plus I3 equal to I2. So that is the first equation from Kirchhoff current law. And then we're going to apply the Kirchhoff voltage law. So here I would suggest clockwise direction because flowing out from the positive terminal of 10 volt, which is also flowing out from the positive terminal of 2 volt. So here we have the positive 10 plus 2 volt equal to the voltage across R1, which is I1. And also here we have another I1 here. So you can see I1 is flowing in this direction. So this is also I1, okay? Since they are series. So here we have 2 plus 2 ohm multiply I1. And then we also have R5, which is 4 multiply I2. Okay, so simplify the equation. And we have the second equation for the DC circuit. Okay, so we're going to get the third equation. So here I would suggest a anti-clockwise direction. So I think you should understand why we choose the direction. Okay, but doesn't matter, you just maybe get a negative terms in between during the process. So here we have 6 plus 2 watt, since they are flowing from the positive terminal of the battery. And then here as well, we can see there's I3 here. So here is I3. So I3 is following the direction of the loop. So we have 3 plus 3 I3 plus 4 I2. So that is the third equation. Simplify, we have 8 equal to 6 I3 minus 4 I2. So it is enough to solve the question. But for practice purpose, let's build a fourth equation from the DC circuit. So here I would suggest we can draw a clockwise direction, okay? Because like what I mentioned just now, 10 volt is bigger than 6 watt. So maybe I would expect the current will flow in this direction. So here we can build it. So it has 10 watt minus 6 watt. So 6 watt because the loop is flowing into the positive terminal of the battery. And then we're going to find out the voltage across each of the resistor. So seems a bit complicated. So need a little bit slow down to solve the question. So we have 2 I1. Okay, plus, okay, so this should be minus because I3 is not following the direction. So minus 3 I3. And then we have the also minus 3 R4, 3 I3. So which would make it 6 I3. And then here we have plus 2 I1, so which is also 4 I1. And then we can simplify it. We have 4 equal to 4 I1 minus 6 I3. So you also can use this equation to check your answer, but just need 3 to solve the equation. And I will leave also the simultaneous solution for you to do it on your own. And the answer will be listed here. So we're going to look the last question for today, which is from Puchong, and it is quite a little bit complicated. So let's see the question. So we have the circuit, and this is 5 ohm. Okay, 5 ohm, the R is 5 ohm, and the EMF here is 20 watt. So others are given as well. So we're going to find the readings of the ammeter and voltmeter and assume the meters to be ideal. So what is ideal? So we have learned how to build the ammeter and voltmeter using a galvanometer and a resistor during topic 15.3. So need to recall back so you can understand why the meter is ideal. So let's say about the ammeter. So ammeter is built by a galvanometer connect in parallel with a shunt resistor. So if you remember that the shunt resistor, it should have as small as possible. Okay, the resistance should be as small as possible, that ideally it is equal to 0. Okay, in ideal cases. So why it should have 0 resistance is that it will have 0 voltage. So when you have 0 voltage across ammeter, so it will not affect any of the reading in the circuit. Okay, just like how we learned about the effect of the internal resistance in the battery, that it can cause voltage drop across the circuit. And as for the voltmeter, it is a galvanometer connect in series with a multiplier. So the multiplier should be as large as possible, that it is approximately to infinity in an ideal cases. So when you have infinity resistance, so there is no current flow through the voltmeter, so it will not affect the current reading or the voltage reading in the circuit. So when you have ideal meters, so what are you going to do is that you short the ammeter, short circuit, and you open the voltmeter. Okay, so you're going to ignore the voltmeter. So it means that there's no current flowing in the flow through the path. So here we can see this is a circuit which is one path AEDC, and another path EAC, and another path is EFBC. So something like we have like the one before is something look like this. Okay, so now we can just apply Kirchhoff law and get at least 3 questions to solve it. So first is Kirchhoff current law. So we can notice point E here. So we have the I1 flowing in, E3 flowing in, while I2 is flowing up. So we have I1 plus I3 equal to I2. And then we're going to apply Kirchhoff voltage law. So here I would suggest we can draw a anti-clockwise direction. Okay, because flowing out from the positive terminal of 12 volts and also the 20-watt battery. So here we have 12 plus 20 equals to the voltage across 5 ohm, which is, okay, follow direction. It has positive 5 I1. And for 2 ohm resistor, you can see that I3 is not following the direction of the loop. So we have negative 2 I3. So that is the things you need to take note. Okay, so simplify, you have 32. Okay, we're going to look for the next loop. So here I would suggest we can draw a clockwise direction. Okay, so this loop is, okay, so don't be confused by the voltmeter because it is now open circuit. So we have positive 8 and positive 20. So 8 plus 20. And then the voltage across 2 ohm. So we have a negative since it doesn't follow the direction of the loop, 2I3, negative 2I3. And then we also have a negative 7 multiply I2 because I2 is also not following the direction. So we have negative 7 I2. So either clockwise or anti-clockwise, you will get the similar equation just about the negative or the positive sign. Okay, so here we have 28. So you can solve these 3 equations and you can get the value of each of the current here. So for the 4th equations, so we can draw a, so I would suggest draw a anti-clockwise direction. Okay, so let's do it. So it has to be 12 minus 8, okay, equal to 5 I1, positive 5 I1. And then we have, okay, so you can see I2 is following the direction. So we have positive 7 I2. Okay, so yeah, that's all. So here we have 4 equal to 5 I1 plus 7 I2. So that these are the 4 equations you can get from the DC circuit. So here I'm going to the conclusion about the meter reading. So the answer for I1, I2, I3 are listed here. So we can conclude that I2 and I3 are in opposite direction as denoted in the diagram. So I2 is flowing up here, while I3 is flowing from point E to point C. So now we're going to find the readings of the ammeter and the voltmeter. So ammeter here is reflects the value of I1. So for ammeter, the answer would be the value of I1, 3.93 ampere. And then for the voltmeter reading, so you can actually apply Kirchhoff voltage law, that you treat the voltage law as a source of EMF. Okay, so let me show you how. So for example, we're going to treat like maybe the current, so we know the current is flowing this direction. So we can actually like, maybe we can say that VB, okay, the point at B has higher electric potential at point A. So this is VB, this is VA. So VB has higher potential than VA. So you can actually like, this is a positive, this is a negative. So we're going to treat voltage as a type of EMF source. So we're going to draw a clockwise direction. So here we have the VB minus VA is VBA. So here is flowing out from the positive terminal of 8 watt plus 8 watt equal to 2 ohm multiply I3. Okay, 2 multiply I3. So here we can just solve it and you can get the answer of VBA. And we also can have another loop to get the value of VBA. So let's see here. Okay, so we can also apply the loop. So I think it is good that we can apply the clockwise, or maybe we can just apply anti-clockwise because we want to follow the same assumption here. Okay, So VB still higher than VA. So we have VBA minus 20 volt, okay, because 20 is not following the conventional direction. And then we have negative 7 multiply I2, which is 2.24 ampere. So if you calculate these two, if you solve these two equations, you should obtain this almost the same answer. And I will leave it for you to find it yourself. So that's all for my discussion today. So if you still have any problems regarding Kirchhoff law, you can ask it in the Telegram group, or maybe you can leave it in the comment section below. So I will see you in my next video. Thank you.